Greetings of the day, students. My name is Dr. Sarika Joshi. I am the Assistant Professor at AISSMS College of Hotel Management and Catering Technology, Pune. Under the series of Bridge Course Chemistry, the earlier sessions were based on the properties of matter and also about the effect of heat on them. We have seen concepts like evaporation, fermentation, etc. And today's session is based on one of the important concepts, that is pH. In this session, the objectives covered will be the history of pH, that is potential hydrogen, the meaning and the definition of pH, the pH scale, and the importance as well as the application of pH in everyday life as well as in scientific terms, especially related to the food industry. So let me introduce you to the concept of pH. In chemistry, pH is a numeric scale which is used to specify either the acidity or the alkalinity of a particular substance. If the negative logarithm to the base of 10 of the acidity of the hydrogen ion. Solutions with a pH less than 7 are supposed to be acidic, and those who have the pH level more than 7 are supposed to be alkaline in nature. The solutions which have a pH level very close to 0 are called as very close to 7 are called as neutral pH. So let's see the definition of pH. pH is a measure of the activity of hydrogen ion in a solution. The activity of the hydrogen ions can be expressed most conveniently in logarithm units. So pH is defined as the negative logarithm of the activity of hydrogen ions. The equation is given on the particular slide, wherein pH is equal to activity or logarithm of the hydrogen ion. What is the meaning of pH? The exact meaning of the P in the pH is disputed, but according to the Carlsberg Foundation, pH stands for power of hydrogen. Another suggestion is that P stands for the Latin term pondus hydrogeni or potentia hydrogeni or potential of hydrogen. So from this slide you must have got a little bit information about what is the meaning of pH. Let us see the concept in further details. So there are certain indicators for pH that will define the pH value of a particular solution. Indicators may be used to measure the pH by making the use of the fact that their color changes with the change in the pH. Can you see a colorful coding given on the slide? As we discuss this concept further, you may introduce to this scale. Visual comparison of the color of a test solution with a standard color chart provides a means to measure the pH accurate to the nearest number. More precise measurements are possible if the color is measured using spectrophotometer. Universal indicator consists of a mixture of indicators such as there is a continuous color change from about pH 2 to pH 10. The indicator or the change in the colors are given in the adjoining figure. Universal indicator paper is made from the absorbent paper that has been impregnated with the universal indicator. So this is particularly used to measure the pH. The measurement of pH can also be done with the help of pH meter. Let me explain you the concept. The pH meter is an electronic device used for measuring the pH. So far we have seen the scale wherein the pH was measured on a paper. This is an advanced version wherein the pH can be measured with the help of an electronic device. The pH will indicate if the solution is acidic or whether the solution is alkaline in nature. pH meter works in liquid, though special probes are sometimes used to measure the pH of semi-solid substances. So the meter is been given or shown in the adjoining figure, which is used to check the pH of a particular solution. A typical pH meter consists of a measurable probe or an electrode which is connected to an electronic meter which displays the meter reading. So in the figure you can see that the pH is measured and 4.16 is the indication which can be seen on the pH meter as a reading. There are certain more pictures which explains that how a pH meter works or how it can be introduced into a reading. A separate material will be provided for you to understand more of use of pH meter into liquids and into semi-solids while using them in laboratories. This concept is majorly used in the food industry, where the pH of a particular substance or a solution has to be measured. Only then the batch is passed for further production or further packaging. Now, how does a pH scale looks like, or what are the indications on the pH scale? So as we already understood that pH is used to measure either the acidity or the alkalinity of a particular substance. So acidic or basic are the two extremes that describe the chemical property. A substance that is neither acidic nor basic, of course, is neutral. The pH scale ranges from 0 to 14. A pH of 7 is a neutral. A pH less than 7 is acidic in nature, and a pH greater than 7 is basic in nature. Can you see the adjoining figure wherein the pH scale is mentioned? Next to that, you will also be able to see certain food products whose pH is typically ranging from the particular scale units, that is either from 0 to 14. So as on the scale and on the figure, you can see that certain food items such as lemon juice will fall into an acidic meter or acidic level of pH, whereas milk is considered to be neutral, having a neutral pH, and there are certain things like a soap solution which will be basic or alkaline in nature. So many further examples can be given wherein you can then be able to judge the pH of a particular substance. The pH scale is a logarithmic and a result. Each whole pH value below 7 is 10 times more acidic than the next higher level, and each whole pH value above 7 is 10 times less basic than the next higher value. So there is this relation between the lower pH and the higher value of pH as shown in the figure. To give you certain more examples of the various items which can be differentiated on their pH values, falling into the acidic category, you may have lye or ammonia. Then you have baking soda, which will fall into an alkaline category, milk, which will fall into an alkaline category, whereas lemon and vinegar will fall into an acidic category. So as the pH level decreases, the particular substance is more acidic in nature, and as the pH level increases, that is, it goes beyond 7, the substance or the solution is more alkaline in nature. Now pH in nature, certain examples. The pH dependent plant pigments that can be used as pH indicators occur in many plants, including hibiscus, red cabbage and red wine. The juice of citrus fruits is mainly because it contains citric acid. So anything that is acidic in nature has a lower pH. You can say in these cases the pH can be as low as 2.2 or anything to range between 2 to 3. But as discussed earlier, even a slightest change in the level of pH is about to or bound to have a tremendous effect on the texture of that particular food. pH in the living system, some examples. The pH of different cellular components, body fluids and organs is usually tightly regulated in a process called as acid-base homeostasis. The most common disorder in the acid-base homeostasis is acidosis, which means an acid which is overloaded in the body. Alkalosis in the opposite condition, with the blood pH being extensively high. Yes, this example states that the blood in our body also can be measured for its pH and is usually a little towards acidic in nature. The pH of the blood is usually basic with a value of 7.36, that is a little after the neutral level. This value is often referred as physiological pH in biology and in medicine. At times when we see that we have a problem related to the acidity in the body, certain alkaline solutions are given which acts as a buffer, or we also call them as antacid medicine, and they help to reduce the acidity, that means to increase the pH level in the blood. Plague can create a local acidic enzyme which can result into the tooth decay by dimining the acidity level. That means if the acidity level of the body is disturbed, it may have certain harmful effects on the body. Enzymes and other plants have optimum pH range and can become inactivated or denatured outside this range. The functioning of the oxygen transporting molecule hemoglobin is also affected by the pH level of the body. So from these examples you can note that how important it is to maintain the pH in the blood. This chart typically may help you understand various types of pH levels maintained in the human body. Certain examples: gastric acid. So as the name itself says, the pH value is 1, that means it is acidic in nature, lower than 7 and moving towards 0. So 1 is pretty acidic in nature. Then you have granules of chromaffin cells, 5.5 as the pH, so again a little acidic in nature. Urine, which may have the pH value of 6, is also acidic in nature. On the other hand, as just discussed, blood or blood cells is more towards alkaline in nature with a pH value ranging from 7 to 7.45. As I said in the beginning, one of the objectives of the pH is also application in the food industry. We will see certain more examples and its application of pH in food industry and its role in maintaining the texture or the appearance of the product in the upcoming session. But before that, it is important to know the pH value of certain food products. So for you to glance or have a quick look, the table explains that or shows that the pH value of apple or any fruit for that matter is little acidic, or for that matter take example of eggs, it is alkaline, cabbage it is acidic. So we can say or conclude that fruits and vegetables are little acidic, especially those which are sour in taste are acidic in nature. Few more examples for reference. Please have a look at the slide and understand and relate more to its pH value. So soft drinks, you can see that the pH value ranges from 2 to 4. So forth and so on with multiple such examples given on the slide. So I hope the concept of pH is understood by you. We shall see its application in the upcoming session. Till then, thank you for listening. Good day.